So welcome to Living Proof, Professor Ben Allanach. Lovely to have you here.
Thanks, Dan. Lovely to be here.
So we've got you behind the microphone today, or in front of the microphone, I should say, because you are going to be our speaker for the Cambridge Festival 2024. As of the time that we're recording, there are 9 tickets left. So it's been really well received, and a lot of people have booked within the first 24 hours that they could. We'll get on to talking about the seminar in a short while. But first, let's introduce you to the listeners. So you work here at the University of Cambridge. Tell me a little bit about your background and what you do now.
Yeah, I'm a professor of theoretical physics in the Department of Applied Maths and Theoretical Physics. So that's on the same site as the in-person talk. And it's the department where Stephen Hawking worked. So I'm in a related research group in the High Energy Physics Research Group, which deals with particles and forces and small things. And of course, he was in the General Relativity Group, which is big things and the universe as a whole and so on. There's a lot of overlap between the two.
Is there any group that does what's in the middle?
Yeah, there are people on the fringes of each. In fact, the groups are very permeable, actually. And there are members in both, in fact. Yeah, we sort of exploit that to our scientific advantage, yeah. So my own history is that I worked at CERN, the European Centre for Particle Physics, between 2000 and 2002. And for 2 years afterwards, I worked nearby and spent a lot of time at CERN. And I'm a visiting scientist at CERN, and I go back and deal with them and their data, work there occasionally. Spent 6 months there last year. And so I'm very interested in the data, in the experiments that are going on there and what they find and so on. And my thing is that I interpret what they find and try and work out what it means in terms of the theories of our universe and what's going on.
It's a really interesting contrast with your work here, because assuming that damped is similar to the Isaac Newton Institute, there's very little more technologically advanced than chalk and a blackboard to use here, and yet CERN is a very high-tech setup.
That's correct. So CERN, of course, is the birthplace of the World Wide Web. It was originally invented to transfer information between experiments, interestingly. And then, of course, it grew into something entirely bigger. But yeah, I was lecturing this morning. I was lecturing a master's course called Supersymmetry. And indeed, we lecture with chalk and talk, we call it. So I was on a blackboard and I come out covered in white chalk dust at the end of the hour.
Excellent. I mean, yes, people can expect that at your talk here if you choose to use the blackboard, because the wall is full of them behind where you'll be speaking.
Great. I mean, I'll be using some slides on a computer screen, but if my big thing during talks is Q&A. So if you turn up to the talk, be sure to think of lots of questions to ask, because I'll be stopping at various points, and I find that really brings the talk to life. And so we may end up on a blackboard if that becomes looks like it's a good idea.
That's great news. And as a question about your talk, what sort of age do you think is a sort of minimum for requirement to enjoy it and get the most out of it?
I actually think that secondary school children could come. If you're interested in science as a secondary school children, so 11 or above,
okay,
you should be able to get a lot out of the talk. I mean, it's aimed at the public. At people who are probably interested in science. Of course, we want to get people in who are less interested in it. But experience shows that you get the ones that are interested. But that's great, and you're all welcome.
That's excellent. So yes, if you're 11 or over and you've got a question, bring it along. You'll even be able to ask it via the live stream as well. We'll have that functionality. I'm getting slightly ahead of myself though. So this is where you find yourself now. Have you always been a mathematician?
Do you know what? I'm really a physicist masquerading as a mathematician. I feel like a bit of a fraud in the department. So I'm a theoretical physicist. So yeah, it's a splitting hairs definition. I use mathematics to model the universe and model what's going on at CERN, for example. In fact, you start off on paper and then very quickly it gets out of your hands and gets too complicated, and you end up putting it on a computer and calculating it with numbers and kind of the equivalent of throwing computational dice and so on. But basically, it's because it's theoretical. Yeah, it's modelling what's going on with maths. But because I'm interested in data, experimental measurements and so on, that's what sort of tags me as more of a physicist than a mathematician. Pure mathematicians are really interested in the logical structure of mathematics and universal truths that once you've set the rules up can't be questioned. Whereas science, you can always question. You can always disprove it with the next experimental result, or say, well, it can be true in these circumstances, but we found a circumstance in which the theory is no longer true. And then, of course, you have to change the theory to make it bigger than the original set of circumstances. So that's very interesting. And I'm involved a lot with that, with looking at the CERN data. So I'm looking for wrinkles in the data that disagree with the current theories. And because then I think we'll learn more about what's really going on.
Fascinating. Yeah, that sounds really, really interesting and a fantastic topic. A fantastic way to get onto the topic of your talk. Now, we've got a really great title for your talk, which is The Force Awakens, Quantum Collisions. Is there going to be a lot of Star Wars content?
Not super much, but there are some wrinkles in the current measurements, apparently. One has to always be careful, but it looks to me like there are problems in the standard theory. So my hypothesis is that these are caused by a new force which we weren't aware of before these new measurements, which is kind of interfering with the way that these collisions happen and what happens afterwards, and giving us these apparent wrinkles. Whereas if we'd included the effects of this new quantum kind of version of a force, we'd be able to explain it. So, all of these concepts I'm going to have to go into during the talk. I'm going to tell you what I mean by a quantum version of a force, and briefly describe the data, not in any technical detail, but try and get something across to the audience.
I mean, that's great. That's what really differentiates this particular talk, which we have every year for this event, for the Cambridge Festival, from, I'd say, the majority of the talks which happen here at the Institute, because they're very, for want of a better word, esoteric mathematical subjects that are touched on here. There's a lot of knowledge required to take part in the talk, whereas this is not like that. You are going to be walking us through the concepts and leading up to this exciting conclusion of those concepts, which is that.
That's right, and that's actually easier. It's fortunate for us because I'll be talking about physics more. I can talk about the machine, things that are very accessible to people. CERN is an amazing machine, and it houses this accelerator called the Large Hadron Collider. It's 18 miles around. It's this massive machine, like from Ghostbusters, that collides beams of protons. It's pretty spectacular stuff. So I'll be showing pictures and videos of that and describing in general what happens there. And I think that can fire the imagination, even if you're if you haven't got a higher degree in mathematics.
Perfect. Well, that's perfect for me then. I will enjoy it very much.
Very good.
So, Ben, I think that's a great overview of what people are going to expect. For the benefit of the listeners, if you haven't been able to get hold of a ticket to attend here in person, there may be some released later, because it's quite often that people get nearer the time and there might be a few cancellations. But it's also going to be live streamed, so you will be able to watch, and will be available to watch afterwards on the site. So there is always going to be a way to catch up with this talk, whether or not you do so in person. But we hope to welcome you here. You'll find all the details in the description of the show. Is there anything else I should be asking, Ben? I'm wondering.
Not that I can think of right now. So thank you very much, Dan.
Okay, well, thanks for joining me this afternoon, and can't wait to see the talk.
Okay, thanks a lot.
Cheers. Bye.